Yes, so I am starting with Coulomb's law. Why? Because for the numerical point of view, so this is where the numerical starts, right? So the earlier topics are what? The earlier topics are the basic properties of the charges, right? And in the basic property of the charges, so you only have one numerical question, which is based on this quantization of charge, right? So that is not that much of important, right? Quantization of charge, which tells that your total charge is integral multiple of this. Right, so this is not important for the, not that much important from the examination, entrance examination point of view, right? So the numericals start from this Coulomb's law, right? So what is the Coulomb's law? You guys already know that if you have two charges, right? And you have some separation R, right? So the force is Q1, K, Q1, Q2 by R, right? This is the Coulomb's law, right, guys?
Yes, sir.
Yes, and let's say what happens. So this is the first question. Let's say that if charges are doubled, right? And the separation between the charges becomes half, right? So then what would be the force? So what would be the new force? This is a very simple question, right? So we know that the old force is how much? So the old force is this. So this was the charge 1 and this was the charge 2, right? And the separation between them was R. So the old force was K Q1 Q2 by R square, right? But now what has happened that the charges are doubled. So this is 2Q1 and this is 2Q2, right? And the separation is R by 2, right? So now this new force would be how much? This would be K, 2Q1 and 2Q2 and R by 2 square, right? Right, guys?
Yes, sir.
Yes, so this would be how much? 4K Q1 Q2 and this is R square by 4. So this 4 goes in the numerator. So this becomes 16 K Q1 Q2 by R square, right? And we can identify this is this old force, right? So the new force is equal to 16 times the old. Right, so if somebody asks what would be the ratio, so the ratio of these would be 16:1, right? This is 16 by. So the force has become 16 times greater than the old force. Right, so this is a very simple question. Okay, you guys just remember this. You guys don't need to write that, right? So do you want to note this down?
No.
Right. So this is a simple. Now the second part is that if you immerse the charges, so if you immerse the charge in the medium, right? The Coulomb's law in a medium. So if you immerse, let's say this Q1 and Q2, and the separation is R, and you immerse this in a medium, right? So now what would be the new force? See, so the old force is how much? old force is K Q1 Q2 by R square, which is 1 by 4 epsilon naught Q1 Q2 by R square. Right. But if you immerse this in a medium, so in medium, this becomes what? The new force becomes 1 by 4 pi epsilon, right? And this is Q1 Q2 by R square. So this epsilon is the permittivity of the medium, right? And this is equal to how much? So this epsilon is epsilon naught K, where this K is the dielectric constant, right? So this force becomes how much? So this force becomes 1 by 4 pi epsilon naught and K and Q1, Q2 by R square. Right, so F medium. So then we can identify this term. So this is how much? This is F Coulomb, which is F air, I can say, right? So F air, right, by K. So this again, you guys already know, right?
Yes, sir.
So this question came in one of the NEET exams, right? So let us do some problems based on Coulomb's law first, right? And then we will talk about the equilibrium later. Okay. So this is the first question, right? This is the first question. You have so the acceleration of an electron due to the mutual attraction between the electron and proton, right? So the charges are given. So Q1 is electron, which is minus E, and Q2 is proton, right? So these are the two charges, and the separation is given. So separation is 1.6 angstrom, right? So what is this in the SI unit? So 1 angstrom is how much? This is how much, guys? Angstrom is how much?
-6.
Yes, minus 10, you said.
Mm.
Right. Did you say -6 or -10?
Minus.
Yes, -10. Right. -6 is micron, right? This is also represented by this, right? 10 to the power -6. Okay, yes. So, and what is given? The mass of electron is given. This is 9, 9 into 10 to the power -31. So in this question, they are asking about the acceleration of the electron, right? So what do we know? We know the Coulomb's law. The Coulomb's law says that this is K and this is E, and again this is E by, we are only talking about the magnitude, right? So that's why I neglected this negative sign. So this is R square, right? And this force would be, so this electron is accelerating, so this would be mass into A, right? And K E square by R square, right, guys? So K is how much? K is 9 into 10 to the power 9, right?
Yes,
So
yes,
M into A is 9 into 10 to the power 9. E is 1.6 into 10 to the power -19, right? And then 1.6 into 10 to the power -19. Okay, R is 1.6 into 10 to the power -10 meter. So 1.6 into 10 to the power -10, and then 1.6 into 10 to the power -10. So 1.6, 1.6 cancels out. And this is how much? So MA is 9 into 10 to the power 9, and this is minus 38, right? And this is 10 to the power minus 20, right, guys? And
Yes,
the
sir.
mass of, yes, and the mass of electron is also given. So the acceleration would be 9 into 10 to the power 9 into 10 to the power minus 38. And this is m, which is 9 into 10 to the power minus 31, right, into 10 to the power minus 20. Okay, so this becomes a, which is 9 cancels, and this is 10 to the power 9, and this is 10 to the power minus 38, and these guys comes in the numerator, so this becomes 31 and this becomes 20, right? So the total positive is how much? 31, 9, 40, and 20, so 60. And minus 38, so this is 10 to the power 22, right? This is the acceleration. Okay, understood, guys?
Yes, sir.
Okay, so please note this down, and then we will do the next question. Okay.
Done, sir.
Done. Yes.
Done.
So the next question is a similar kind of question that that we did. We changed the charges, right? So this is exactly the same question. Okay, why this is not? Yes. Let me put this here. Okay, so these are two charges, right? Okay, what has happened? Okay, why this is not working? I should not be. Okay, so let me cut this part and start this. Okay. Okay, start my notebook. I'm restarting my notebook. One moment, guys. Okay. Yes, now can you guys see my screen?
Yes, sir.
Yes. So this is the question that yes. So 2 point charges A and B having charges plus Q and minus Q, right? And are placed at a certain distance apart and forces acting between them is zero, right? So two charges are there, two charges plus Q and minus Q, right? And they are separated by some separation R. And the force is how much? Force is KQ square by R square, right? This is the force between them. Now, if 25% of charge A is transferred to B, right? So A is a positive charge, remember, and B is the negative charge, right? This is point A, this is point B. So 25% of Q is how much? Yes, 25% of Q. So this would be 25 by 100 into Q. So this is Q by 4, right? So this much of charge is removed or is transferred. It is removed from A, right? So this A charge will be how much? QA would be how much? This would be Q minus Q by 4, right, guys?
Yes, sir. Yes, sir.
So this would be how much? This would be 3Q by 4, right? And now this charge is added to this minus Q, right? So QB would be how much? This is minus Q plus Q by 4, right? So this is how much? This is minus 3Q by 4, right?
Yes, sir.
So the new charges are 3Q by 4 and this is 3Q by 4, right? And the separation separation is R. Okay. So what would be the new force? This would be K, and this is 3Q by 4 and 3Q by 4 and R square, right? So this is 9KQ square, and this is 16 R square. So this is how much? This is 9 by 16 KQ square by R square. So this is KQ square by R square is how much? This is our old force, right? This is our old force. So when we plug this value, so this becomes how much? 9 by 16F. So your new force is 9 by 16F. Right, guys? Any doubt in this question?
No, sir.
Okay, so please note this down, and then we will learn about the equilibrium. Okay. Noted, guys?
Done, sir.
Yes.
Yes, sir. Done.
Okay, so this is so the next topic is equilibrium, right? So there are two kinds of equilibrium. Uh, right, there are two kinds. One is that one point is at equilibrium, right? And the other kind of equilibrium is that the system is in equilibrium, right? So what do I mean by these two guys, right? So let's say I say that you are placing a charge, right? So this is some charge q and this is some charge q, right? Both are plus q. And in the center you are placing some another charge plus q, right? So at this point, this will force, so this is, let's say this total distance is r, this is r by 2, this is r by 2, right? So at this point, there would be two forces that are acting on this charge, right? So force due to this charge, right? Let's say 1, and this is 2. So F1 in this direction and F2 in this direction, right, guys?
Yes, sir.
So now this point is at equilibrium, right? So this charge, this only charge is at equilibrium, right? But if you can see that, if you can calculate the forces that are acting on this charge, so forces are acting due to this 3. So F3 would be here, right? And F2 would be where? So F2 would be here, right? Right, guys?
Yes, sir.
Yes, sir.
So this point is not at equilibrium, right? Not at equilibrium. So you see that this point is at equilibrium, but this point is at this is not at equilibrium, which means that your system is not at equilibrium, right? For system to be in equilibrium, let's say for system to be in equilibrium, all the forces, one. Yes, sorry about that. Yes, so I was saying that for the system to be in equilibrium, the forces that are acting on here. So F net is 0 at this point, right? F net at 0 at this point, and F net is equals to 0 at this point. So if this criteria fulfills, then this system is said to be in equilibrium. Right? Did you understand this part, guys?
Yes, sir.
Okay. Okay, so let's do one problem which is based on the equilibrium at one point, and another question of this system of equilibrium, right? So the first question is that, let's say if you have some charge plus q, right, and plus 4q, and you are placing some charge, let's say q, at this point, which is at x distance from this small q charge, right? So smaller charge. So we have to calculate at equilibrium. So if this point is at equilibrium, so what should be this x? That we have to calculate x so that this q is at equilibrium. Right, guys?
Yes,
So,
sir.
so let us calculate the forces. We have to, at equilibrium, we have to just calculate what is F net, right? So if F net is 0, then this point is at equilibrium. So there are two forces acting on this point, right? One is this F4Q, right? in this direction and FQ in this direction. Right. So at equilibrium, you have FQ is equals to F4Q. So did you guys learn this in your CPSC course?
No, sir.
Okay, so let us do this question then. Okay, so FQ is F4Q, right? This total distance is L. Okay, this distance is X. So how much is this distance? The distance between Q and plus 4Q. How much is that? Let me draw this here. So this would be more clear. So this distance is X. Total distance is L. So how much will be this distance?
And my X.
Correct, correct, absolutely correct. Right. So to use the Coulomb force, we only need to know about the separation, right? So FQ is how much? Separation is X and charges are KQQ, right? So FQ is KQQ by X square, right? And this is equal to how much? F4Q. So K4Q by, and the separation is how much? As Aisha or Aisha said, right? So this is L minus X square, right, guys?
Yes, sir.
So K cancels, Q cancels, Q cancels, right? So we have 1 by X square. This is 4 by L minus X square, right? So this L minus X square is equals to 4X square, right? So then if we take the square root on both the sides, so this is L minus X and plus minus 2X, right? So there are two solutions, and first if we take plus 2X, right? So L minus X is plus 2X. So this would be L equals to 3X and X is L by 3. Right, first is this distance, and the second solution would be L minus X is minus of 2X. Right, so L is minus 2X plus X, so minus of X. So X is minus L. So minus L signifies that this is in this direction. So this cannot be true. So this solution is discarded and we have X equals to L by 3. Right. So to make this charge at equilibrium, we have to place this charge at L by 3 distance from this Q charge. Understand, guys? Understood?
Yes.
Okay, so please note this down, and then we will complicate this question, right? Then we will learn about the system of equilibrium. Yes. In 4 batch, what is this 4 batch? So did you guys learn this in the CBSE course? I asked that. If you learn this, then I will skip this part. Yes, Aisha, did you solve this question in your CBSE course? Okay, so Aisha, yes, okay. Okay, so you are that Aisha. Okay, so sir is the same portion we covered in 4. Okay. Yes, so Rabia didn't do this problem, right? So, okay. Okay, so Aisha, yes, so this is the same, yes, this is the same question, right? But we'll do the next, but Rabia didn't do this problem, right? So, Rabia, did you do this problem in your CBSE course?
No, sir.
Okay, so Aisha, please bear with us. This seems to be repeating for you, but just for one question, right?
Okay,
We
sir.
we will do another question, and then we will learn about the, yes. So tension you already learned, right? Okay. So this would be repeating. Yes. So did you guys note this down?
Yes, sir.
Okay. So in from the next class onwards, I will. So how will I arrange? Because how will I manage? Because Rabia is not doing this problem. Okay, let me see from the next class what I can do. Right, so the next part is that when your system is at equilibrium, right? So what happens is that you have these three charges, right? And this is plus Q, and this is some charge, and this is plus 4Q, right? This is plus Q, this is 4Q, right? So in the system of equilibrium, what is the charge that you put that your system is in equilibrium? So if you put minus Q charge, right? So the force at this point is, so due to this charge, this is in this direction. So this is FQ, right? And for this charge, this is 4Q, right? This total is distance is L, this is X, right? So for this part to be in equilibrium, right? And this is second part, and this is third part. So for this part in equilibrium, your FQ is F4Q, right? And for this part, what are the forces that are acting on this charge? So one force is minus Q, which is attracting this. So this is FQ, right? And one force is due to this charge. So this is repelling this, right? So this is F4Q. So for the second point to be in equilibrium, your FQ is F4Q, right? Right, Rabia. Aisha already learned this. So sorry, Aisha, that
Yes,
this
sir.
It's
is
okay, sir.
yes. So first, let us calculate what is this FQ is equals to F4Q. So we have already calculated this, right? We have already calculated FQ is equals to 4Q. So this will give the position. So X will come out to be L by 3, right? Now let us calculate FQ, which is equals to F4Q. So FQ is how much? FQ is this. That separation is X, right? And charges are Q and minus Q. So FQ is equals to F4Q. So FQ would be how much? This is K Q by X square, right? And F4Q is how much? So for F4Q, this is the separation, L, right? Separation is L, so L square, and the charges are K, Q, and 4Q, right? So Q cancel, K cancels, and Q by X square is 4Q by L square, right? So Q is how much? Q is 4Q by L square and X square. And you know X square is how much? You know X square is L by 3, so L square by 9. So L square cancel, and you have 4Q by 9, right? And this is negative. So minus 4Q by 9. So this is how your system is in equilibrium, right? Understood, Rabia?
Yes, sir.
Okay, so please note down this part, and Aisha, you don't need to write note down this part.
Done, sir.
Okay, so let us do some problems based on this. Okay, so this question we already we already did. This for this question we need to learn about the tension as well, right? And again, right. Yes, so let us do this sixth problem, right? So for this problem, this is the Coulomb's law problem, right? Two positive ions, each carrying a charge Q, are separated by a distance d, right? If F is the force of repulsion between the ions, the number of electrons missing from the each ion would be, right? So we know that what would be the force? So the force would simply be kq square by r square, right? This is d square. Okay, this is a very simple question, right? And we know that from the quantization of charges that q is how much? This is n, right? So F is this k is 1 by 4 pi epsilon naught, right? And q square by d square. So q square is how much? Q square is f d square by this is how much? F4 pi epsilon, right? And you have, right? So this is q square. Okay, and q square is ne square, right? So ne whole square is f d square and 4 pi epsilon, right? So this is n square e square, and this is f d square by 4 pi epsilon, right? So your n would be how much? Or n square would be f d square 4 pi epsilon naught by e square. So they are asking about the number of electrons, right? So the number of electrons would be how much? This would be simply root of how they have written. So 4 pi epsilon naught and f d square by e square, right? This is a very simple question based on the Coulomb's. So there are two theories that we needed to know about. So one was the Coulomb's law and the second was the quantization of the charge. Okay. So which is the correct option? This is the correct option, right? C is the correct option. So you guys please note down this part, and then we will do the next question. Okay, so again, Aisha, I'll be repeating what I taught you in your morning class, right? Morning or the evening. Because you see that all these questions, right? So all these questions are based on that tension part that you learned. So that is why I will have to repeat that. Okay.
Okay, sir.
Okay, so please note down this, note it down, and then we'll do the next question.
Done, sir.
Okay, Aisha, done?
Yes, sir.
Okay, so the next topic is that you can combine Coulomb's law and equilibrium with so you can combine the Coulomb's law with equilibrium and with another force, which is tension, right? So how do you do that? Let's say first, what is a tension, right? So as you learn in your 11th class, that if you hang something which has some mass with a string, right? So this has some mass, so this will pull down. So this will pull it downwards, right? So the weight will be acting upon this, and string will try to pull it in the other direction, right? So the tension will be acting on this in the opposite direction. So this will be balancing this weight, force due to gravity, and this string will pull it in the other direction to balance this weight, right? So this tension will be equal to this mg, right? This is the tension, okay? And if this tension acts with some angle, right? So let's say this is the tension, and the string is hanged like that, okay? So the string is hanged like that. So the tension is acting with some angle, right? So if we draw this, the tension is in this direction, and this is the angle theta because of the alternate interior angles, right? So this is theta, this will also be theta. And from the vector class, we know that we can write the two component of this. So this base will be t cos theta, and this horizontal will be t sine theta, right? So the tension has two components, this vertical component and this horizontal component, and the weight is acting downwards, right? So this is the tension at some angle, okay? Aisha has already learned this. So did you understand, Rabia?
Yes, sir.
Okay. So how the Coulomb's law and equilibrium is combined with this tension. So let's say you have a system like this. You have a system like this, where your charges are hanged. Two charges are hanged, right? This Q charge and the another charge Q, right? And they have some separation, let's say, so 2r. And this is acting with some angle theta, right? So this is r, and this is also r, okay? And the strength of the length of this string is L, okay? And as you already learned, that this string will try to pull this in its direction, right? So the tension will be acting in this direction, right? And this is the angle, okay? So the tension will have two components. This is t cos theta, and this is t sine theta, right? And the weight is acting in the downward direction, okay? And what are the other force? What is the other force that is acting? Rabia, can you identify what is the other force on this charge? So this charge is at equilibrium. What is balancing? So this vertical t sine theta is balancing this weight, right? What is balancing this t sine theta? Because this is at equilibrium. There must be a force which is acting in this direction. What is that? Can you identify that? Rabia. So whenever you see two charges, right? Two charges, then there must be a Coulomb force, right? So this charge will repel this charge in this direction. Am I correct, Rabia?
Yes, sir.
So this is the Coulomb force that is balancing this tension, right? Right, Rabia?
Yes, sir.
So this is the free body diagram, which is at equilibrium for this charge, right?
Yes, sir.
So we have T sine theta, which is balancing the Coulomb force. Okay. And then we have T cos theta, which is balanced by the weight. Okay. This is 1, this is 2. Let's divide 1 by 2. So we will get what? T cancels, and sine theta by cos theta is tan theta. Right. So tan theta is Fc by mg. Okay.
Yes, sir.
And in this question, they ask you what is the magnitude of this charge, right? So this is the question, right? So we have to calculate what is this charge. Okay. So we know that Fc is mg tan theta, right? Right. And
Yes, sir.
yes, and what do we know about this Coulomb force? So the separation is 2r, right? Separation is 2r, and the charges are QQ. So our life is simple, right? The Coulomb force would be KQQ by R 2R square, right? Right, guys?
Yes, sir.
And so this is KQ square by 4R square mg tan theta. Right, so Q square we want to calculate. This is 4R square mg tan theta by K. And K, we know this is how much? So this is Q square is 4R square mg tan theta, and K is for 1 over 4 pi epsilon. So this is 1 over 4 pi epsilon, right? So Q square is equals to 4 into 4 is 16. R square, let me write 5 epsilon naught R square mg tan theta. Right. So this is root over. Okay, guys. So this is the charge. Right. Did you
Yes, sir.
understand? Yes. So did you understand this part? Aisha, we didn't do this part, right?
Yes, sir. Yes, sir.
Okay. So please note down this part, and from where should I put the screen? Yes. So this is. Please note down this. And whenever you need to write more, so please tell me that I need to scroll down. Then I will scroll down this. One more thing
Sir,
is
can you,
that, yes,
sir, can you
yes.
show the final answer Q?
Okay, so final answer is this. So you reached this part.
Yes, sir. Done.
Okay, and what about Aisha? Did you write down this part?
Yes, sir.
Okay, so where should I put the screen? Here.
So till the end,
Huh?
till the final answer.
Oh, final answer. Yes. And one more thing that we can do is here is that this is your theta, right? This is your theta, this is R, and this is L, right? So this is theta, this is P, right? And this is H. So what trigonometric identity relates P and H? So what is that trigonometric identity? Do you guys remember? Which relates P and H? Can you guys recall? Sine theta is P by H, right? So P is R and H is L. So sine theta is R by L. So we can write R as L also, right? So we can write in place of R square, we can write this also. So this is 16 pi epsilon naught L square sine square theta mg tan theta. So this is also the answer. Okay, guys.
Yes, sir.
Yes, so any doubt in this problem?
No, sir.
Okay. Okay, so today I'll be taking only 1 hour class, and from the next time onwards, I'll be taking 1.5 hour classes. Okay, because this class happens only once in a week, right? This happens only one day in a week. So that's why I need to take 1.5 hour to try to catch up what is happening in your CBSE course, right? So from the next time onwards, I'll be taking